Section 7.1 concerns solving equations with variables on both sides or each side of the equation. We're just going to work through several examples of these so that you can see it's the same technique, but you're actually trying to put the variables together on the left-hand side is where we're going to go. So we see this, and we're going to move that over first. So remember, the way that we move that or get rid of that is we're going to add a negative x or negative 3 to both sides. So you're going to have 2x equals 3x minus 3. But I have an x on this side and I have an x on this side, and I want to take this 3x and move it over here and join it with the other x. So I'm going to add a negative 3x to both sides. Okay, if you want, you can go plus a negative 3. Okay, then you come down here, I've got a negative x equals a negative 3, because if I have a positive 3x plus a negative 3x, that cancels out. I've got to get rid of that negative 1 that's in front of it, so I'm going to divide both sides by a negative 1, and it's going to change both signs. So I have x is equal to positive 3. Now to check it, you would plug it back into the equation, and everywhere there's an x, you're going to substitute the 3. So I have a 2 times 3 plus 3 is equal to a 3 times 3. So 6 plus 3 equals 9, which is true. So you're doing the same techniques that you've been doing before, but this time you have a variable on both sides. So on this one, I'm going to get rid of this 12 first. In other words, I want to move it over here. So I'm going to add a negative 12 to both sides. Now you understand that the 2x and the negative 12 cannot be combined because one has an x and one does not. So on the left-hand side, I have 5x. On the right-hand side, I have 2x minus 12, or plus a negative 12. I want to take this 2x and move it over here, so I'm going to add a negative 2x to both sides. So a positive 2x plus a negative 2x cancels each other out. So on the right-hand side, I have a negative 12. On the left-hand side, I have a 5x plus a negative 2x, which is going to give me a 3x. Well, the 3 is multiplied by the x, so the way you get rid of it is you divide. So I divide both sides by the 3, and I get x is equal to negative 4. Now, you're very welcome to plug it back in to check it, but I am not going to require you to do that, even if it says it on the homework. So you're definitely welcome to do it to make sure that you got the right answer. I'm not making it mandatory. All right, now that, same concept, but these problems are maybe a little bit more complicated. And as we work through these problems, they're going to get more complicated as it goes forward. Hopefully that'll focus in there in a minute. Okay. That looks a little bit better. So if you notice on this one, I've got a 4 that needs to go over here, but now I've got another number over here too. So I'm going to subtract the 4, or add a negative 4, and that's going to give me on the left-hand side, those go away, so I have a 5x is equal to 3x, and these two I can combine, so that's plus a negative. So I have a negative 2 and a negative 4, so I've got a negative 6 on this side. I want to take the 3x and move it over here to join it with the 5x, so I'm going to add a negative 3x to both sides. So I'll have a 2x on the left-hand side. Those go away. I still have the negative 6 on the right-hand side. The 2 is multiplied by the x, so to get rid of it, I must divide by it. So I get x is equal to negative 3. Okay, here's another one very similar. I'm going to add a negative 3 to both sides to get rid of that plus 3. So I have a 7x on the left-hand side. and then I have a 2x plus 21 on the right-hand side. I need to move this to join it up with that 7x. So I'm going to add a negative 2x to both sides. So I'm going to get a 5x. These two cancel out. So I have a 5x equals, oh, that's not 21, that's 20. 5x is equal to 20. I'm going to divide by the 5 because the 5 is multiplied by the x, and I'm going to get x equals 4. All right, let's go a little bit harder. Okay, notice these have some decimal values in it. Now, if you wanted to, again, needs to focus in. Take just a second. Okay, you could multiply through to get rid of the decimal. That would be one way to do it. It might make it easier. Let's go ahead and do that. Notice that I would need to multiply by 10 to move the decimal one place to the right. Now, you do not have to do this, but you're certainly welcome to. But remember, you have to multiply the whole thing by 10. So this becomes 24 plus 10a equals 25a minus 45. Okay, and so now all the decimals are gone, if you will. So I need to get rid of this 24 and move it over here. So I'm going to add a negative 24 to both sides. On the left-hand side, I'm left with a 10a. On the right-hand side, I still have 25a. These two are both added because they're negative, so it's plus a negative 69. I need to move this to the left-hand side, so I'm going to add a negative 25a to both sides. So that's going to give me a negative 15a on the left-hand side and a negative 69 on the right-hand side. So I'm going to divide by negative 15. Now notice it does not come out even. So I've got this fraction, and it's going to be positive because I have a negative divided by a negative. But I also know that I can divide both the top and the bottom by 3. So I divide it by 3, and I get a 23 on the top, and I get a 5 on the bottom. If you want to turn around and make it into a mixed numeral, 5 goes into 23 4 times with 3 left over. So either one of those answers is fine. All right, let's do another one like that. Again, I can multiply everything by 10 to move the decimal. So that's going to give me 17 plus 10a equals 25a minus 49. I want to move the 17 over, so I'm going to add a negative 17 to both sides. So that's going to give me 10a on the left-hand side equals 25a plus a negative, let's see, that would be 63. I think that's right. No. Negative 66. All right, so I'm going to subtract the 25a because it needs to go over to the left-hand side. Okay, and so the opposite of adding the 25 is subtracting it or adding a negative. Goes away here. Again, here I have a negative 15a, but this time on the right-hand side I've got a negative 66. I'm going to divide both sides by negative 15. Doesn't come out even, so now I have a fraction that's positive because it's a negative divided by a negative, and I'm going to divide the top and the bottom by 3, which is going to give me a 33 over 5, or a 6, because 5 goes into 33 6 times, with 3 left over. Okay, let's go one more complication here. Now I've got fractions, and I want to do this problem with fractions. would be persuaded to multiply through to get rid of the fractions. So if you look at the bottom, they both have a 5 on the bottom. So if I multiply this whole thing through by a 5, it's going to get rid of my fractions. So this is going to give me a 20 over 5y minus 40 equals, that's going to be 10 over 5y plus 80. So this is going to give me a 4y minus 40 equals 2y plus 80. So this is kind of where I was on the other problems. So I can add a positive 40 to both sides to get rid of it on the left hand side and to move it to the right. So I have 4y equals 2y plus 120. I'm going to add a negative 2y to both sides. So I have a 2y is equal to 120. I'm going to divide by the 2, and I'm going to get y is equal to 60. So you can always multiply through to get rid of your fraction. If they have different denominators, you would multiply through by the common denominator to get rid of it. Now, you do not have to get rid of it. You can leave it as it is. All right, your homework is page 332, 11 through 33 odd.